The figure shows a circle of radius 6 along with the origin and 3 labeled points on the xy plane. If the coordinate of x are 3 and negative 3 root 3, what is the measurement of angle AOX? So, okay, if we're dealing with coordinates and you're dealing with a non-unit circle, which means the radius is in this case 6, you're going to view it like this. In a previous video, I kind of broke things down where I reminded you that sine theta, or whatever it is that we're talking about, is y over r, right? And if I multiply both sides by r, I now get r sine theta equals y. Similarly, cos theta is x over r. And if I multiply both sides by r, I now have r cos theta equals x. Why does that help us? Well, now I have a y value, now I have an x value, and I can write these guys out as points. So my x is going to be r cos theta, r sine theta. That's my point. It gives me the coordinates. So the coordinates are actually going to be 3 equals r cos theta. And by the way, theta is going to give me the angle measurement of, not AOX, it's going to be giving me the angle of BOX, so I have to be super careful with that. Super careful with that. But anyway, not there yet. 3 equals r cos theta. So maybe I could just deal with that. I know that r is 6. So 3 is going to equal 6 cos theta. Dividing both sides by 6 says cos theta equals 3 over 6, which is a half. Now, since I'm looking at this point down here, I remember that cos theta has to do with the x value. Okay, when I move from the x-axis and I do the whole square root over 2 stuff, okay, I know I'm going to have 3 dots, right? I'm going to have 3 dots, and the first dot is going to be root 3 over 2 for my x value, then root 2 over 2, and then 1/2. So this x value is going to be this dot right here. This dot has to do with the radian measure 5 pi over 3. Now this 5 pi over 3 considers the whole thing. I don't want the whole thing. I want AOX. So rather than do the whole thing, I'm going to subtract out a pi from this. So minus a pi is 5 pi over, so basically just subtract 3 over 3, and you get 2 pi over 3. So a very, very, very bizarre problem, very potentially confusing, but, you know, these aren't supposed to be easy. They're just supposed to be fun, and it was.